Hey everybody, my name is Kyle Rames, and I'm a developer advocate for Rackspace. And today I'm hopefully going to cut through some of the fog of cloud for you. Whoop, there we go. On the agenda today, we're going to have just a brief 5-minute like Cloud 101 to go through some of the basic cloud concepts. And then we're going to actually jump in and start working with clouds using Ruby. So we're going to actually see some code in this talk. So what is cloud? Cloud is starting to think about consuming computing resources like a utility, much like the power that comes out of the electric outlet. You're going to pay for compute time by the hour. You're going to pay for file transfer and storage by the megabyte. And much like the power, it's going to be seemingly infinite. Now, there are 3 different types of cloud computing out there. The first is software as a service, which I'm sure everybody here is very familiar with. Everybody's used Gmail and GitHub. So I'm going to jump past this one and talk a little bit about platform as a service. Platform as a service is where you're going to take your Rails application, your Sinatra application, really any rack application, and you're going to upload that to your cloud provider, and they're going to run your application within this little walled garden. They're going to take care of a lot of the system administration for you. They are also hopefully going to take care of most of the security for you, and they're also going to get you a decent way towards developing a scalable solution. The problem with platform as a service is when you want to do something outside of that context of that walled garden. Maybe there's a service you want to run that's not offered by the cloud provider. Maybe there is a binary or a gem with a native binary that you want to run, and your platform won't let you do that. And that kind of brings me to our third type of cloud, which is infrastructure as a service. This one's my favorite. It's really the Lego mindstorms of the cloud world. You're going to get a whole bunch of cool little pieces, like a compute piece, an object storage piece, a load balancer piece, and you're going to be able to put those together in seemingly infinite number of combinations. You'll typically see the different types of cloud expressed in a pyramid diagram like this, with infrastructure as a service at the bottom. As I said, infrastructure as a service is the most flexible type of cloud. And as you go up that pyramid, your flexibility is going to reduce. You're not really going to be able to add features to a software as a service, for example. As we go down the pyramid, your time to build and deploy a solution is going to go up. It's much easier to go to GitHub and type in your credit card information than it is to provision a whole bunch of servers and install Git on there. And then I wanted to talk to you about a couple of your cloud options. When I say cloud, you typically think about the public cloud. The public cloud is where you're going to get the cheap computing resources that are going to be nearly infinite. But there's another type out there called private cloud. And this is where you're going to go out, you're going to buy your own machines, or you're going to rent them from an internet hosting provider, and you're going to install some cloud software on there. You're going to get the benefit of having a programmable infrastructure, but it's probably going to cost a little bit more for you, and it's not going to be quite as infinite. Consequently, there's a third type that's emerging called hybrid. And hybrid, it allows you to partition your code between portions that are more secure and maybe a little bit less secure, and that kind of allows you to take advantage of the security in some places and that cheaper infinite amount of cloud resources in others. And the last thing I wanted to touch on is when I say cloud, you probably typically think of a closed cloud. A closed cloud is where if you're interested in knowing what's happening with your cloud, you can't really look at the source code. If you want a new feature or something for your cloud, the best you're going to be able to do is fill out a comment card. And you're definitely not going to be able to run it wherever you want. And here to tell you today that you actually have the option of selecting an open cloud, much like OpenStack that we heard about today. OpenStack today is his third birthday, by the way. And with an open cloud like OpenStack, you can go to GitHub, you can see the source code, you can actually submit pull requests, you can work with the community to add features, and you can also run that in both a private or a public environment. You can download a distribution of cloud install on your own servers, or you can use a company like Rackspace or HP that actually have an open cloud and move transparently between those different environments. So that was basically kind of a brief Cloud 101, and now let's actually jump in and start manipulating the clouds using Ruby. And for that, we're going to actually be using the Fog gem. Fog is the #1 cloud SDK according to rubytoolbox.com. It's got over 2 million downloads. It has over 300 contributors. Actually, I think it's closer to 400 now. And it's a very active project. It has anywhere from 30 to 60 commits per week. And chances are, even if you're not using Fog, you're using Fog, because Fog powers a lot of our favorite gems, such as Paperclip, Carrier Wave. It's used by Chef, and it's used by the Puppet Provisioner. And it's also used by Rum, which is a new utility that Rackspace is launching here today at LoneStarRuby. And Charles Lowell is going to be talking a little bit more about that in his session. I also wanted to take time to point out that I'm actually a top contributor to the Fog project. So if you actually have any questions about Fog, whether it's running with Rackspace or Amazon or HP, please feel free and come up and talk to me after the presentation. Now, to see a list of the providers that are available in Fog, we're going to do fog.providers.keys. And you can see it's going to spit out a whole bunch of different providers. I think there's about 36 of them right now. Some of those are just strictly DNS-based providers, but others, such as Rackspace, Amazon, HP, OpenStack, those actually have a full suite of services. And we are going to choose Rackspace today because I know everybody here is a big fan of open clouds, and I love fanatical support. So let's go see the services that are available to us through the Rackspace provider, and we're going to do that by calling fog.services, and that's going to return a hash. The key for it in that hash is going to be the service, and the value is actually going to be a list of the different providers that support that service. And you can see here through some Ruby code, and this will probably be the most complex Ruby code we see today. You can see a list of the different services that are available with the Rackspace provider. We are going to be looking at compute_v2, load balancers, and then DNS. And for the eagle-eyed among you in the crowd, I'm sure you noticed that there's actually two different compute services. Compute v2 is for our next-gen servers, and unless you have any legacy servers, you should really be using the Compute v2 version. So we're going to start off by looking at a sample architecture that we're going to create using Fog. We're going to provision 2 cloud servers, a load balancer, and then we're going to add a DNS entry that will point to that load balancer. And we're going to start off looking at the VMs. And so for that, we're going to go ahead and create a compute service. So we're going to do fog::compute.new. Then we're going to pass in a hash. And the first key value pair in that hash is that provider, which is, again, Rackspace. And this is going to return this is what's going to make it return the Rackspace implementation. And then the rest of the key value pairs are specific configuration parameters for that service and that provider. So you can see here we're specifying v2, for a version. That's why we're going to get back that compute underscore v2. We're also going to pass in the credentials, and then we're going to be using the Chicago data center today. Now, there are actually 3 pieces of information that we're going to need to create a server. The first is an image, and this could be Ubuntu, FreeBSD, Windows, Arch Linux. It could actually even be an image that you've created off of one of your running servers. Then we're going to need the flavor, and the flavor is more or less the server configuration. It's going to be a combination of memory, disk space, and number of CPUs. And that's actually where a bulk of the cost of your cloud server is going to come from there. And then if you pick an image that requires a license like Windows or Red Hat. And the final piece of information we're going to need is actually a name. So we're going to start off by getting a list of images. So we're going to do service.images, and this is going to return a list full of, I think it is 30 different images on the Rackspace Cloud. These are going to include what we like to call base images, as well as, again, any of those user-created images. And I, for better or worse, an Ubuntu man, so we're going to get the Ubuntu image, and so we're going to do that by doing images.find, and then we're going to do a regular expression on Ubuntu. And you can see that we got back a raring ringtail image. Next, we're going to need the flavor. So we're going to do service.flavors.first, and that's going to return the cheapest cloud server Rackspace has, which is a 512 meg configuration. And the last piece of information, again, is the name. And I wanted to pause here and talk a little bit about that, because as we all know, naming things is one of the 2 hardest problems in computer science. The other 2, of course, being cache invalidation and off-by-1 errors. And when we go to pick a name, we actually want to pick something that's very disposable, something that we're not really going to remember. And that's because we're not really going to develop a relationship with this cloud server. It's not like our laptop or old Bessie that's running in a data center somewhere. We're going to use it, and then we're going to throw it away. So I'm going to pick what I think is a pretty disposable name, TK421. And now that we have these 3 pieces of information, we're going to go ahead and we're going to create a server and pass in our image, our flavor, and our name. And then we're going to get back a server object. And as you can see here, that some of the values, some of the attributes that we have for the server are nil. And that's because we've actually scheduled the creation of the server with the Rackspace Cloud. It hasn't been built yet. So let's go ahead and reload it to get the latest state. So we're going to do tk_421.reload. And you can see some of these values have actually populated. And if we want to actually grab one of these attributes programmatically, we can do server.attributes. You can see this is going to spit out a hash full of our attributes. And Fog is also going to provide us a little bit of meta magic. So we can actually do tk_421.state. We can see it's in a build state. And we can also check the progress. And you see that this cloud server hasn't done anything yet. So let's go ahead and reload it to get the latest state. So you can see if we do server.state, it's still in the build state rather. And then if we do server.progress, you can see that we're actually 17% done. And as you notice, this is actually a very common pattern that emerges whenever you're dealing with cloud resources. And because of that, Fog actually has a mechanism called wait for. And what wait for is going to do is it's going to go ahead and reload it like we've seen before. And then it's going to do an instance eval on that block. And in this block, we actually have a ready method. So it's going to do, in essence, server.ready. And that ready implementation differs between different services, different providers, and different objects. For our particular server here, it's going to mean that it's in an active state, that it is at 100% progress, and that we've allocated an IP address, because without an IP address, the server's really not much use for us. If this block evaluates to false, it's going to sleep for a second or 2, and then it's going to repeat that process, and it's going to continue to do that until that block turns true, or 10 minutes has elapsed and it'll throw a timeout exception. You can see here that our server finished in a little over 3 minutes. And now that our server is ready, we can go ahead and get our login credentials. And we can do server.username and server.password. When you create a server on the Rackspace cloud, it's going to give you that, it's going to populate that password attribute for you. When you subsequently retrieve it, it's going to be missing. So you should either persist it when you have it, or you can go ahead and change the password. Personally, I actually prefer to use SSH key authentication, and I'm sure you do as well, because it's a little bit more secure and a little bit more convenient. And because of that, Fog actually provides another mechanism called Bootstrap, and Bootstrap's going to go ahead and create a server, and it's going to wait for the server like we've already seen, and then it's going to go ahead and then create that authorized key file for us. It's going to lock out that password for that root user, so that password we had we wouldn't be able to use it anyway. And then it's going to create an attributes and a metadata JSON file, which is going to contain information about the server when it was provisioned. And you can see here that the Bootstrap syntax is very similar to the create, and then with the addition of a couple new attributes, the public key path and the private key path. And once this Bootstrap method finishes, we can actually start using the server. And Fog provides an SCP and an SSH method, so we can actually go ahead and manipulate it. So you can see here, I'm going to SCP up a setup script to root/setup, and then I'm going to remotely execute it. And you can see that it results in saying that it's setting up the VM. And you don't really have to just use this for setup scripts. We actually have a group at Rackspace that uses this mechanism to do load testing against another one of our open source projects called Repose. Repose is a reverse proxy into our cloud that handles authentication, rate limiting, a whole bunch of other good stuff. We've actually just barely scratched the surface of what you can actually do with a cloud server, and I would encourage you to go dig in and look at the documentation to learn a little bit more. Now we're actually going to pause, and we're going to talk a little bit about what we actually have seen. If you remember, one of the first things that I did was service.images. That actually returned a collection back to us. Up at the top, you can see that this collection inherits from array, and that's why I was able to use the first and find methods. Under there is a fog : collection. That's just some basic internal guts that's not particularly interesting. And then under there is the concrete implementation for the images class. And those concrete implementations will typically contain all of these methods. The first being all, and you haven't seen me actually use the all method, but I've actually been using it everywhere. Every time I go to access a piece of data from that hash, it actually calls this because it does some lazy loading. If I would have known that ID for that Ubuntu image, I could have actually gone ahead and retrieved that directly using the get method. And then there's also a create a new method, and that kind of reinforces the RESTful nature of our cloud. If I would have used new, it would have created a local copy in our VM, and create actually creates not only that local copy, but that remote server as well. I can get the list of collections that are available to a service by doing service.collections. You can see here that there are actually 5 different collections that are available for our compute service, 3 of which we've already used: servers, flavors, and images. And the last 2 are attachments and networks. Inside collections, of course, are models. Here again is a class diagram for that. And these are some of the methods that models typically implement. We've actually already seen all of these. And this collectively, this is actually known as the model layer in Fog. Now let's actually go back to our example and see if we can apply our newfound knowledge of the collection mechanism in Fog. As you can see here, we actually have our two servers that are running, but there's no way to kind of know which to balance the requests. So we're going to go ahead and throw a load balancer into the mix, and we're going to do that by starting off and creating a load balancer service. You can see here that the syntax is a little bit different than what we used for the compute service. The namespace actually includes rack space, and that's because there is not yet an abstraction for load balancers. Fog actually typically waits until there's 3 or more different services before it develops an abstraction. And of course, because there is no abstraction, we don't need to supply the provider key value pair. So we're going to go ahead and see what collections are available in the load balancer. So if we do load balancer service.collections, you can see there's load balancers and nodes, which we'll be using to set up our load balancer. So to create a load balancer, we're going to do load balancer service.loadbalancers.create. We're going to go ahead and populate some parameters. We're going to give it a name. We're going to use the HTTP protocol on port 80. Then we're going to specify our virtual IP addresses of type public. This is actually going to create both an IPv4 and an IPv6 address for our load balancer. And then we're going to go ahead and then give it a node. We're going to give it the IP address for TK421, its port, and as well as the condition. If you try to create a load balancer without specifying any nodes, it's actually going to error out on you. So we actually have to include this. And of course, I forgot our second VM, so we're going to go ahead and add that programmatically. We're going to do load balancers.nodes, which again is a collection that sits on our load balancer.create. Then we're going to go ahead and supply the same information we did for TK421. Now to get the address for that load balancer, we can do load balancer.virtual-IPs, and we're going to go ahead and locate the IPv4 version. Once I do that, I can do a virtual IP.address. Yeah. It's been allocated by the service, so it is valid. And if we would go pull out a web browser and go to that IP address, it would return a request from either one of our two servers. Now, just to kind of give you a little bit of a taste of what you can do with a programmatic infrastructure, I'm going to show you a little bit of continuous deployment. So if we go ahead and create two new servers, TK602 and TK603, with newer versions of software, we can go ahead and add those nodes like we did before. And then we can take our existing nodes, TK421 and TK422, and we can set the condition to draining. So the load balancer will no longer send any requests to those two nodes. And then we can wait for about 10 to 15 minutes to see how the new software is doing on 602 and 603. If it is doing well, we can go ahead and just kill off those nodes. We're going to stop paying for those extra services. Likewise, if something was wrong with those one of those two nodes, we could actually reverse the process, enable TK421 and TK422, and kill off 602 and 603. So now that we've seen how the model layer works inside of Fog, using both the compute service and the load balancer service, I wanted to talk about the second layer that exists, and that's the request layer. The request layer has a one-to-one mapping between the remote cloud and Fog itself. It's going to be the most efficient way to access the cloud, but it's not going to be portable between different providers. And for that reason, that's why Paperclip and Carrier Wave and Puppet and Chef all prefer the model layer, and you should too. The only reason you'd actually ever want to use the request layer is if there was a feature in your cloud that was not available through the model abstraction. And to see the list of requests that are available for a service, we can do service.requests. You can see these are some of the methods that are available for the storage service that Rackspace has. So let's go ahead and wheel our example back out, and let's go ahead and see how we would add a bestbinmining.com at a DNS record to point to our load balancer. So again, we're going to start off by creating a new DNS server, and we're going to do that by doing fog::DNS.new. We're going to specify the provider because there is an abstraction available for DNS, and then we're going to pass in the credential information. And hopefully this is all starting to feel very repetitive to you. This is actually by design, and once you realize this pattern, you should be able to pick up any service that's available inside of Fog, like the database server, monitoring, what have you, and apply the same pattern. So we are going to, just for purposes of illustration, use the request layer to create this new record. We're going to start off again by doing DNS service.requests, and you can see a list of requests that it supports. We're going to be looking at the list domains and the add records method. So when I do service.listDomains, it's going to return an XCON response. XCON is the underlying HTTP library that's used by Fog, and it has this object has some interesting data on it that I wanted to point out. You can see that we have our data, and that response from the server has automatically been translated from JSON into Ruby objects by XCON. The second piece of information I wanted to point out were the headers. These are the HTTP headers. With a lot of different cloud services, you'll see that they use the header mechanism to transfer data. This is particularly seen inside of storage services where the data that we're pulling back is the file. And then the last piece of information is the status. And you can see we got a 200 OK back, so this was a valid request. So let's see how we would programmatically access this information using Ruby. So we're going to do response.body. We're going to grab that domains hash, and we're going to search for a hash inside of that array that has a key of name that contains a value of Vespa mining. You can see that that was returned here. And then again, just to show you, you can do response.status, and that will return our 200 OK. So let's go ahead and add that record. We're going to go ahead and grab that IPv4 address from our load balancer like we did before. And then we're going to go ahead and use service.add_records, and then we're going to pass in that ID that was in that domain hash that we just found. We're going to specify a name of Vespa mining. It's going to be a type A record, which is an IPv4 record. If we wanted to create an IPv6 record, that would be a AAA. The data, of course, is going to be the IP address of our load balancer. And we're going to specify an optional time to live of 5 minutes. And that completes our example infrastructure. Obviously, this example was for illustrative purposes. If this was actually a real architecture that we were going to use for a real solution, we probably would want to include a data source like a database or maybe a NoSQL database service, set up some monitoring. We could also set up some private networking between the VMs so that they weren't accessible through the internet. And now that we've actually seen how Fog works, I wanted to actually do a deep dive and find out a little bit more. So let's go ahead and try to retrieve our Ubuntu image. I suddenly remember the ID for that rearing ringtail image that I looked at earlier. So we're going to do service.images.get. This is going to go into the images collection class, and we're inside the get method. And you can see here that the collections class is actually going to use the request layer. Inside of Fog, the model layer should never access the HTTP layer. It'd be really bad if it did be a leaky abstraction. So going down a layer into it, we can see the actual request method that we're sending out. Request is a method that's on our service. We are going to expect to get back a 200 or a 203 from our cloud. If we don't get that, XCon is going to go ahead and throw an exception for us. We are going to use the get method to retrieve the information about the image. And this is actually the path on the Rackspace Cloud to that image. And this will result in the following HTTP request going out. You can see here our get verb. The first part of that URL is actually going to be our service endpoint. Now, when we originally created our services, it actually went out and authenticated against the Rackspace Cloud, and we looked up that service endpoint for the Chicago data center, and that's our endpoint. There, of course, is the extra path that we specified. We're setting some additional headers. We set a content type, and we also say that we are going to expect to get JSON back. Obviously, you don't need to specify that content type for a GET request, but that's the way Fog currently does it. And the last piece of information I wanted to point out was the Auth Token. And this was another piece of information that we received from the cloud when we authenticated against it. This token should be valid for about 24 hours, and it identifies all of our requests to the cloud. And if we were interested in seeing detail like this when we were programming with XCon, we could actually export the following environmental variable, XCon_debug equals true, and we'd be able to see that request response coming back from XCon, which is obviously particularly important for debugging. And then the last thing I wanted to briefly touch on was testing. Fog actually provides a mocking framework if you want to incorporate Fog into some of your testing. You can enable that by doing fog.mockbang, and that should return dummy data for each request. You could also use the VCR gem to go ahead and then record some of those, requests and test against that as well. And that's my presentation. All right. Thanks for coming, guys.